Hi, Algebra 1. This is going to be on page 191. We are starting with something called scatter plots. And a scatter plot is how you plug in data. So if you had data points and you were to see it plotted, like on our example, we can make a line of best fit. So there's two different examples. This one on the right side of your paper doesn't have a line of best fit, but we have line of best fits. So there seems to be some sort of equation as y equals mx plus b. That would be our line of best fit. A couple of new words. We're going to talk about positive versus negative. Sorry, I can't spell. Correlation. All this means is if you have a positive correlation, your slope is a positive slope of your line of best fit. So it would look something like this or something like this. You know, some sort of positive line. It could be really steep if you wanted it to be. A negative correlation means your slope of your line of best fit would be negative. So it could look like this. And I don't have the XY axis drawn. You can go really steep with these. So when you see or hear the word correlation, know that it's referring to the slope of the line. The slope of the line is positive, the correlation has a positive correlation. If the slope of the line is negative, you have a negative correlation. Okay? And you can have strong and weak positive. Okay, so the y-intercept, if I had graphed something and I had drawn a line of best fit, this would be my y-intercept, okay, which is 0, comma, b, where b would represent a number. The x-intercept is going to be where it crosses the x-axis. So if we had a line of best fit here, that would be the x-intercept. The x-intercept is some unknown number, comma, 0. When we talk about strong, moderate, or weak correlation, we kind of look at the data. So strong correlation, this would be a strong positive, this would be a strong negative, meaning that our line of best fit would fit right on those dots. Moderate positive might look something like that, and that would be a moderate positive. Moderate negative correlation might look something like this. And then a weak correlation, if you looked at it, it just kind of goes all over the place. You know, where's our line? How can we make a line of best fit? For each of these, I can make a line of best fit amongst my data. This one has to go this way, this way, this way, this way. I don't know. We don't know. Down at the bottom of page 91, we have R equals 1. This is a strong or a perfect correlation. Correlation is an R value. Okay? If I had the next one, so this is R equals 1, which would be our dots fit right in perfect. And so if you look at those as you go across, you'll see, you know, an R of 0.8, the data points are a little bit scattered. And then if you have an R value of 0.3, your R value or your points are kind of scattered. You can kind of see a line about it, but they're kind of scattered. No correlation. R equals 0 is going to be our data just looks like a blob of stuff, like you threw a bunch of mud against the wall, what it would look like. Okay, and then we can have our negatives. So R equals negative 0.3. That would be data kind of all over the place, but you can see that it's going downward. And R value as we go across of R being negative 0.8, that means it's a little bit tighter together data. It forms a pretty good straight line. And an R of negative 1 is a perfect straight line of our data. Okay, go ahead and flip the page over to page 192. So letter A for the blank, the independent variable, independent, if I could spell, are the x values. So the independent variable are the x. So if we look at our graph that we have drawn over on the right side, this says temperature. So our independent is temperature. Okay, it's the x value, whatever it's titled. The y value is the dependent, which is the y value, which in this case is going to be visitors if you look at your graph. So this will be visitors. Now, we need to figure out the equation of the line of best fit. So I'm going to try and do the best I can drawing this data table over here. Okay, so what we want to do is we're going to try and squeeze a line of best fit. So you just kind of have to estimate. Now just know, my line of best fit might be a little bit different than yours, and your person who's sitting next to you might have a little bit different. So what we're going to do is we're going to do this, and we're going to try and figure out the 2 points that are the furthest away from each other. They don't have to be right on the line, but the furthest away from each other, and we're going to estimate them. So it looks like on the graph, this looks to be 82, 80 maybe. I'm just estimating it. I might not be exact. This point up here looks to be about 96, maybe 530. Okay, so those are my 2 points that we're going to use. So for letter C, I'm going to pick the 2 furthest away points that are pretty close to being on the line of best fit, because realize you don't have a line of best fit drawn there. So I'm going to pick these 2 data points. Okay? So from there, what we're going to do is we need to create our equation. So I'm going to call this x1, y1, x2, y2. We've been doing this. So the slope equation is y2 minus y1 over x2 minus x1. And you definitely want to have a calculator handy when you're working this kind of stuff, because you start getting into some larger numbers, and we'll just do the best we can with what we have. So I have 536 on top, and I have 80 also on top. And then I have 96 minus 82. So 536 minus 80, I'm going to do that on a calculator, gives me 456. And then I'm going to go 96 minus 82 on a calculator, which gives me 14. Now, sometimes it's better to make your slope, make it a decimal. Okay, it's not all the time, it's just sometimes. But this one, I'm going to go 456 divided by 14 on a calculator, and that's going to give me 32.57. So I know it looks funny that you have a slope that's a decimal, but sometimes it makes this a little bit easier. Okay, so now let's figure out our equation over a line. Well, I'm going to pick this value here because it's x1, y1. I'm going to plug in to our point slope, which is this equation. You could have picked either of the points. It doesn't really matter. I just picked the first ones. So remember, when I plug in my y1, it's going to be opposite. So it's now a negative 80. It was positive 80 up top. I'm not going to have my fraction slope. I'm going to have my decimal slope. Okay? And this, you're going to see why this is going to make a little bit more sense, especially if you have a calculator to use. And then I have x minus 80, or x minus 82, excuse me. Okay, we want to clean this up a little bit. So what I'm going to do is I'm going to distribute over the parentheses, so I get y minus 80 equals 32.57 x, and then 32.57 times 82, 32.57 times 82 is negative, because there's a negative sign right there, 2670.74. We're going to add 80 to both sides. Again, you want to keep having a calculator handy when you're doing this. Don't try and do it in your head. Let me know if you need a calculator. I can get you one, okay? So 2670 Negative 2670 plus 80, if you plug that into a calculator, we're going to come up with an answer of negative 2590.74. That is our linear equation based on the data from the data up above. So does it have a positive or negative correlation? Well, you can see that in one of two places. You can look back saying, well, that looks like it has a positive slope because it's rising as I go to the right, or you could just look at what the actual slope is. The slope is positive, so it has a positive correlation. And then what is the slope? The slope, you go ahead and use the fraction, 32.57. That's totally okay. Okay, it looks goofy, but it works when you're dealing with this kind of stuff. So explain what the slope means in the context of the problem. So you're going to do something that's kind of strange. You're going to make a decimal become a fraction, and the fraction will have the decimal in it. Remember, the y value are the visitors. The x values is the temperature. And this is what this means in the context of the problem. You get 32.57 visitors more if the temperature is 1 degree warmer. Okay, now, can you really get 0.57 of a person? The answer is no. So these don't have to be exact values. Sometimes they make silly sense when you're reading it. Okay, explain what the slope tells us to the situation. So this is the answer for E. Okay, so you have the slope here and the answer to it. And then what is the coordinates of the y-intercept? The y-intercept, so for letter F, the y-intercept, remember it's 0, b. And remember on our equations, y equals mx plus b. This b value here and this b value here means the same thing. All right, so our y-intercept is 0, negative 2,590.74. What does this mean in the situation? If it is 0 degrees, then negative 2,590.74 people at the beach. Now, can I have negative people at the beach? No. So it doesn't always make sense, but that's what it means in the context. So it looks if you're working with somebody, you might look at them and saying, you're being silly. It shouldn't be that way. And then we're going to use, for letter G, use our equation to see what happens at 85 degrees. Okay, so my equation was up there. So y equals 32.57 x minus 2590.74. Okay, so this is a temperature. Temperature was our x value. So I'm going to take 85 and plug it in here. And you definitely want to use a calculator when you're doing this. Okay, this is not something you want to do in your head. So if you do the math, I'm going to go 32.57 times 85 minus 2590.74. So that's going to say that there's 177.71. Okay. So this means that we have 177.71 people at the beach when it is 85 degrees outside. And again, can I have a fraction or a decimal of a person? The answer is no. But it doesn't have to make 100% sense. It's just what it's telling us. Letter H says predict if we have 500 visitors. We want to predict the temperature. Okay, again, I'm going to use my equation, which is here, 32.57x minus 2590.74. And what I want to do is the visitors, remember, was y, so I'm going to plug 500 in here. And then we're just going to work out the problem. Add 2590.74, add 2590.74. So these cancel out over here. So 2590.74 plus 500 is 3090.74. That's equal to 32.57x. So let's get x by itself. Those are multiplied together, so I'm going to divide to undo it. And again, you want to have a calculator. So you're going to go 3090.74 divided by 32.57, and x is going to be 94.89. So we would have about, I'm going to use that, 95 visitors to the beach if, or it would be, I just made a mistake, I'm so sorry. It's X, that's temperature, isn't it? It would be 94.89 degrees temperature if 500 visitors on beach. So you're using this to predict some stuff, okay? All right, this is kind of a lot. So page 193 and 194 are what I'd like you to work on for next time. Do all of them, okay? Try all of them. You might have to work with each other to get all the words. There's not a lot of work there. I mean, number 5 on that page, on page 193, it's going through that type of problem. So you might want to have to refer back to this video to see how I do stuff. On number 5, the independent variable is the depth of a scuba diver, and the dependent, the y value, is the water temperature in Fahrenheit. So please talk to me if you need any help. I'm happy to help you. Have a nice day.